notes are mostly a review of some stuff that you probably already know. So this is the stuff that we're going to go through somewhat quickly. Just because it's review, we're just going to make sure that you guys know this stuff. And that if you are rusty on it, that we are jogging your memory. So if you have a triangle, we have two different ways we can classify triangles. We can classify them based on their angles. We can classify them based on their sides, okay? So if a triangle has three acute angles, anyone remember what acute angles are? Smaller than 90. So if a triangle has three acute angles, it is called an acute triangle. Acute triangle. It's cute because its angles are little. Get it? It's look at this cat food for my kitties. I'll take video for you. I'll show you how much my little cat likes cat food. You have cat allergies. Savannah, you have cat allergies. If you have one obtuse angle, and you can't have, are we listening? You can't have more than one obtuse angle. Why? Yeah, because the angles of a triangle equal 180, and an obtuse angle is more than 90. So you can't have more than one of those because that'd be over 180 already. So if you have just one obtuse angle, you call that an obtuse triangle. If you have one angle in the triangle that's 90 degrees, you call that a right triangle. And then if you have three congruent angles, what would the measures be of those three congruent angles? 45. Not 45. 60. They'd all be 60. 60, 60, 60. And what would you call that triangle? Not equilateral. Equiangular.
We haven't learned that. Yeah, what?
Equiangular triangle. It would also be equilateral, but if we're talking about the angles, then it would be equiangular. The angles would be the same. Equiangular. It would also be equilateral, but we're not classifying it by its sides yet. Equilateral means the sides are the same. So if I'm like, hey, the angles are the same, what do you call it? And you're like, equal sides, we call it equal sides. It's like, well, yes, but no. That's weird. Don't call it equal sides if we're talking about the angles. I'm like, if this person is white, what do you call them? And you're like, tall, we call them tall. And it's like, okay, maybe they're also tall, but that's not what I'm talking about right now. So if the angles are the same, we call it equiangular. Okay, it is also equilateral. Yes, you are right. Okay. All right, if we look at this picture, triangle, let's look at it. Triangle CDE. How could we classify triangle CDE? Right triangle. Right triangle. Okay. Triangle BCE. If you are a notebook person, don't worry about writing these down. BCE, obtuse. Okay. Triangle ABE. Equiangular. Triangle BDE. BDE. Obtuse. All right. CFE. CFE. Acute. Ooh, Jack, you think that triangle is cute, huh? Oh, on the triangle in front of everyone. CFE is Jack's girlfriend. CFE is Jack's girlfriend. Jack, are you blushing beneath that mask?
I am.
All right. Now, you guys know this one. Three congruent sides is called equilateral. There we go. If the triangle has two congruent sides, it's called isosceles. 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 It's Isosceles. All right, and then what is a triangle that has no congruent sides? Scalene. 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 What if we had a math spelling test? We would put scalene, we would put isosceles, and we would put asymptote. Wednesday's not a math spelling word. Here, if you guys want to put markings on this one just to show that they're different, you could do that. All right. JKM. JKM. JKM is scalene. Scalene triangle. Okay. KLM. KLN. 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 Isosceles. JKN. Equilateral. Okay. All right. So for the next one, we're going to classify it by its angles and by its sides, because we can do both. Okay, so we could say it's acute, and maybe it's equilateral, equiangular. I guess you could do all of those, because technically an equiangular triangle is also acute. You could do it's isosceles, but it's also a right triangle. You could do it's isosceles, but it's also obtuse. You could say it's scalene, but it's also obtuse. You could say there's a lot of different combinations out there. So we're going to give its different classifications, and there's two of them, one by angles, one by sides. Okay? So for the first one, what are the two classifications we can see? Right isosceles. Right isosceles. Okay? What about the next one? It is obtuse. It almost looks like it's isosceles just visually, but they didn't label it to show us that the two sides are the same, so we cannot assume that. So we have to say scalene because we don't know for sure. That was good to notice that. Okay, what about 11? Yeah, equiangular, equilateral, and if you said acute, you are not wrong. It is also acute. Okay. All right. Next page. Notebook paper people, how are you doing? You good? Okay. Whew. All right, number 12. What is number 12? Acute scalene. Okay. What's number 13? Right scalene. What's number 14? Obtuse isosceles. Okay, circle. 15, 16, 17, 18, 19, 20 are going to do those. Notebook paper people, you do not have to draw that when you do it. You can just do it on your notebook paper and call it good. Okay? So we're going to do those. Yes, Macy. Yes. So notebook paper people, when you do this one, you don't necessarily have to draw the picture if you don't want to. But I do want you to answer all those questions later when you get a chance. Okay. Next, we're going to classify triangles in a coordinate plane. So with this, it is helpful to have, if you're classifying them based on their angles, drawing a sketch of these in the coordinate plane is going to be helpful so you can kind of see what the angles are. But to classify them based on their side lengths, how are we going to find the lengths of the sides from coordinates? Avery. The distance formula. Yes. Does anyone remember the distance formula? Did somebody make popcorn and burn it? I'm smelling it through my mask. You are not smelling that. Alex, is your sniffer broken? Yeah, I think Alex's sniffer is broken. Yeah, it's whew. Whew. Pete says that's so bad I gotta blow my nose. Get it out of there. Whew. All right. So the distance formula: distance equals square root. Are we ready? Of x2 minus x1 squared. Is this ringing a bell? Plus y2 minus y1 squared. Oh, squared, not to the 1. It is based on the Pythagorean theorem. That's where it comes from. You should have learned it in middle school, because you didn't learn it in high school, because I didn't teach it to you.
We read a book about it. Oh, yeah.
You read a book about it?
Yeah, he was like building,
we didn't do much
he was
on
building a ladder, I think. Because we missed 8th grade math. Like, we just didn't have it.
So we had like a combination.
We read a book.
Interesting.
Because it's a sub thing. It's like not a square thing.
Yeah.
Now I smell it.
I like how the question was, can we close the door? And by we, I mean Pete. So this is the formula. It's how you find the distance between 2 points. So the points are x1, y1, x2, y2. And you just subtract the x's and square them, subtract the y's and square them. So what we're going to have to do is we're going to find the distance between j and k. We're going to find the distance between k and l. Then we're going to find the distance between j and l. Because if you think about it, the triangles are classified by the length of all 3 sides. So we can't just find the distance between 2 of the points, because that only tells us the length of one side. We got to know all 3, right? I'm going to try to draw a pretty realistic drawing here off to the side, and if I can't do it very realistic, then I have to get graph paper out. So it's got to be, you got to do a pretty good job, okay? So I'm going to do, it goes left 9. That's the furthest left that it goes. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it goes down 7. That's the furthest down it goes. 1, 2, 3, 4, 5, 6, 7. Ms. Rice, why are you drawing this? I'm drawing this because I want to see if I can draw a picture and see what kind of angles it has. So at least I can do that classification by the picture. Does that make sense? Because I'm not going to do that classification using math. I'm just going to do it by drawing it. All right? Make sense? Make sense? Okay, okay. So 1, 2, 3, 4, 5, 6, 7. 7. Okay, there's J. -9, 1. -1, -1. This is K. This is L. Well, there we go. So we can already see one of the classifications, can't we, just from carefully drawing our little picture? What's the first classification you can see? Acute. Okay. So for 21, I'm going to say acute is first. Now, if you draw a sketch and your sketch is too sloppy and you can't really see it, or if you're trying to draw a sketch and you still can't really see it, then go ahead and grab some graph paper and draw a sketch and you'll be able to see it more clearly. Okay? So we definitely can see acute. And so now what we're going to do is we're going to go ahead and start doing that distance formula so that we can start to see what the lengths of the sides are. Make sense? Okay. So I'm going to start, and then I'll do KL, and then I'll do JL. Okay, so JK, I'm going to do -7 minus -9. It doesn't matter which order you do, as long as you're consistent. So I'm doing X minus X. And then I'm going to do Y minus Y. -7 minus 1. Everyone comfortable with that? It doesn't matter. As long as you're consistent, it doesn't matter. And the formula might even be X1 minus X2. It honestly does not matter as long as you're consistent.
I remember being like,
Yeah, I know for the slope formula, it's y2 minus y1 over x2 minus x1, so I was just being consistent with the slope formula. Huh? Nope. It just uses the same notation. Yeah. All right, so we did x minus x, y minus y, and we're squaring them both. Everyone comfortable? Okay, so there is our J and K. So now I'm going to do K and L. So I've got -9 minus -1 and 1 minus -1. Comfortable with that? We good? X minus X, Y minus Y. Good? Yes? Okay. I've got X minus X and Y minus Y. Oh, they happen to be the same. Okay, so now I'm ready to so I'm going to do it once. Your negatives and your minuses are going to be really important here. So -7, my -7 is that short little negative, and then minus, that's long, -9 squared, and then -7 short minus 1 squared. So look at how I've typed that in. Ooh, very nice. So everyone go ahead and type first, and let's make sure we can all get the same answer. So you didn't square root. So you got the number underneath the square root. That's fine. So I typed in the square root. I got approximately 8.246. Okay. Okay, I'm going to type in the next one. Oops. Now, if you're having a hard time with the minuses, which is very easy in this case to have a hard time with the minuses, then you could just change these minuses to pluses and plug it in that way. It'd be easier to plug in. And then you don't have to worry about the minus, because we know that's how a minus works anyway. So there's my second one. Ooh, I have two sides with the same length. So we've narrowed it down. It cannot be scalene. Everyone see that? It can't be scalene. So we're going for either equilateral or isosceles. Okay. So what is our conclusion? Acute isosceles. Okay. How do you guys feel about that one? Pretty good? Feeling pretty good? Okay. Not so bad? Okay, let's try the next one. I'm going to draw a little sketch off to the side. This one, the furthest left that it goes is 3. The furthest right that it goes is 8. The furthest down that it goes is 1. The furthest up that it goes is 6. The only thing about these is it would be hard to tell if it's got a right angle or not. Now, what I noticed as I looked at the answer keynotes for this is that Gina did not, she did not put an angle on these. She only did the side lengths. The coordinates are -3, 2, 2, 6, 8, -1. This to me looks obtuse, but it could be a right angle at K. Obtuse. I wouldn't know if it's a right angle without doing regular graph paper. Do you guys remember how to know if lines are perpendicular or not? Have you learned that before? Has to do with their slopes.
What's the word? Reciprocals.
Close. Opposite, yeah, negative reciprocals, so the opposite signs. Okay, so we could tell if we had graph paper and we graphed this perfectly, we'd be able to tell if they were a 90-degree angle or not. Okay. Now I'm curious about this one to know if it is a 90-degree. What do you guys think? You think it might be? Do you think we should say obtuse and just move on? Okay, will you guys go ahead and get started on the distance formula and I will draw on notebook paper and we can check it? I'm curious. I want to know if it's 90 because it could. I think it could be. I guess it depends on how accurate your drawing is. Mine looks obtusey, but it looks maybe 90. Oh.
Yeah,
It's 91.
Well, we are pretty far away from a math class where you can figure out exactly the angle. You learn that in calc and pre-cal. How to do non-right triangles. This is looking real, maybe 90. Now that I'm doing it on graph paper. Yeah, it does. It does, doesn't it? Okay, so how are we going to figure it out? Well, we talked already, right? We have to check the slopes and see if they're negative reciprocals. So what's the slope from J to K? Goes up 1, 2, 3, 4 over 1, 2, 3, 4. So it's 4. Goes down 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4, 5, 6. They are not 90. It's just real close to 90.
91.
What? What did you say? It says classify by its size. Gina asked for sides. Lily says, Miss Rice, Gina don't care. Lily said, look, Miss Rice, we're here on a Friday. Nobody else is here at school. All the public schools are out today. Yeah, a lot of schools are off today.
Yeah, I've been allowed to see it. No, that's pretty funny.
Well, we had a whole big the people that I know we had the people that
We got math to do. We got math to do. We had not just one set of notes to do today, but 2 sets of notes to do.
This math
I am not even sorry about it. I'm helping you be smarter. Yes, Seth. It does not matter. As long as you are yes, as long as you are consistent. All right. All right. Are we finding the lengths? Are you guys doing it? Oh, I typoed that one. Okay. All right. I've got my answers up. What have you guys gotten? I am a math teacher. I got magically quick calculating fingers. No, this is one of the nice calculators. It's newer, so its buttons are not broken in yet. Huh? They've been making them for a long time. Yeah. Miss Rice, did they make these back in your day? They sure did. They sure did. Yes, they did. Yes, they did. It was cutting edge technology back then. It is not cutting edge now. It is normal. But it is normal edge. It is blunt. It is blunt. It is blunt technology now. All right. How are we doing? So,
Oh, we're doing, okay, yeah, I got you.
okay. So, what's our conclusion?
I was the last one, yeah.
Learn. Oh, you guys are on 23. All right, circle 23 because you're gonna do that one. Yeah, so, yeah. I said circle it, not X it out. Okay. All right, let's go ahead and move to the next set of notes. No, we are. I circled it. You're doing it. We're just not doing it as a class. What do we need to what? I mean, you can still draw a picture and guess. Make an educated guess. You don't have to. I guess. If you don't want to. Since Gina said you don't have to. All right. Isosceles. Isosceles. All right. Look, isosceles. Now we are going deeper into our study of isosceles triangles. All right. Isosceles triangles. Ready? Are we ready? Isosceles have two congruent sides that are called legs. They're called legs. Here, we can even label this picture. So this is called a leg, and this is called a leg. The angle where the legs intersect is called the vertex angle. The vertex angle. So this angle right up here is called the vertex. The vertex angle. The side opposite the vertex angle is called the base. So this is called the base. I guess. The angles along the base are called base angles. So base angle, base angle. If that looks like base L, then just write the word angle out. Base angle, base angle. Okay. Okay. So the isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. All right, so that means if the legs are congruent, then the base angles are congruent. Does that make sense? If the legs are congruent, the base angles are congruent. So if AB is congruent to CB, then angle A is congruent to angle C. And the converse is true as well. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if the two base angles are congruent, then the two legs are congruent. So if angle A is congruent to angle C, then AB is congruent to CB. And this is probably the most common and most helpful thing about isosceles triangles, is that we have that those sides and those angles are congruent. And one thing that's kind of interesting that you might have picked up on about triangles, but you might not have picked up on about triangles, is that if you have, like, let's say you have a scalene triangle. So in a scalene triangle, since all the three sides are different lengths, you have a small side, you have a medium side, you have a long side. The smallest side is across from the smallest angle. The medium side is across from the medium angle, and the longest side is always across from the longest angle. Does that make sense? So this kind of goes along with the idea in a triangle that the side always correlates to the angle that it's across from. So if you have two sides that are equal in length, then they're going to be across from angles that are also equal in length. Does that make sense? So sides of a triangle correlate to the angles that they're across from. Okay. So that is a big idea about isosceles triangles. That's important. It's going to help us solve problems now, but it's also going to help us solve problems in Math 3. Every so often, problems just pop up in triangles in Math 3, and you go, oh, it's an isosceles triangle. That's helpful. Those two sides are the same, so the base angles are going to be the same as well. And it's just going to help you solve things. So let's look at this problem. Number 1, if L is 68, what's angle J? 68. It's the same because this is an isosceles triangle. We can see that from the two markings on there. So if these are both 68, how can we find angle K? Yep. So we'll just subtract both of those angles from 180. And what do we get? 44. J is 68. K is 44. Okay. All right, in picture number 2, they gave us that the vertex was 106. So if they said the vertex is 106, how could we find the base angles? Okay, so 180 minus 106 is 74. Is that right? My mental math is, oh, I said 108, not 180. So this is 74, and then we're going to go ahead and do 74 divided by 2. And we get 37 and 37. So C and E are the base angles, and they are the same. In example 3, your base angles are the same. So what is the length of side YZ? 12 centimeters. It's the other leg. Okay, 12 centimeters. And then if we wanted to find the measure of the vertex angle, how could we do that? Okay. We get 26. Wow, Miss Rice, those problems were so difficult. My brain hurts. Whew. All right. Next problems. Of the next 4, what do you think we should do? I mean, we'll circle them, but which one should we do as a class? That's not even on this page. Well, okay, which one? Which one? Let's do just one. Number 4. Okay, so I'm going to circle 5, 6, and 7. I might as well do them. Okay, so number 4, they have marked that the sides are the same. So since the sides are the same, that means the legs are the same, so the base angles have to be the same. And if the base angles are congruent, that means we're going to set them equal to each other. So I'll go ahead and get my x's to one side. And then I'll get my x's alone on that side. See, this is a mental health day. This type of math is relaxing. It is. Yes. This is the same as going to the spa. Just let it all out and relax. Yeah. Yeah. No. 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 Okay. Do these look intimidating? What do you guys think? Are the words intimidating? Yes. So which do we want to do? 8, 9, or 10? 8.
I'm doing it right now.
So, do we remember how we put the labels in?
Is R and S equal because both base pairs are congruent?
Wait, do we remember how to put the labels in if it says triangle RST? Yeah, we just go around in a circle. It says RT and ST are congruent, so RT and ST are congruent. If RT and ST are congruent, then what angles are congruent?
R and S.
R and S. Okay, so R is across from ST, S is across from RT, and so that means that those are the base angles. Okay, so angle R is 9x plus 2. Angle S is 13x minus 18. Angle T is 17x plus 1. I don't know why they'd give you all 3 angles. You don't even have to use the fact that this is isosceles. Well, it doesn't make it more confusing because you could just say they all 3 add up to what? Yeah. Yeah. But honestly, I'd rather not use all 3 if I don't need to. So what should I do if I don't want to use all 3? It's interesting they gave us all 3 though. Who knows? So 4x minus 18 equals 2. Okay, so they asked us to solve for x and find the measure of each angle.
Oh, that's why they gave us 3?
But we still wouldn't have needed it. Because if you can find 2 angles, you can find the third one. All right, so which angle do you guys want to find first? R. Okay. So it works out both ways. I tried plugging 5 into 17x plus 1 and it gives you 86, and then I tried it by minusing 47 twice and it gives you 86. So it works out both ways. So there were two different ways to solve this problem. You could either use that it was isosceles and set the two base angles equal to each other. You could do it that way. Or since they gave you a measurement for all three angles, then you could have said all three angles added together equals 180. Both ways would have solved the problem. Okay. Do you guys want to do another one of those, or do you want to leave it? Okay, let's do the equilateral triangles notes. So jump down to the bottom. All right. So equilateral triangles, if the measure of angle B equals the measure of angle C equals the measure of angle, I already said that, then AB equals BC equals AC. So basically they're saying if the three angle measurements are equal, then the three side measurements are equal as well. So if the angles are the same, the sides are the same length. Yeah, let's see. Go ahead and circle 9 and 10. If we are finishing all the notes, then I'll see how long the assignments are, and I'll probably cut them down. All right? So do not stress. If AB, BC, and AC are all the same length, then the measure of angle A equals the measure of angle B equals the measure of angle C. So this is that idea, if it's equiangular, then it's equilateral. If it's equilateral, then it's equiangular. They both happen at the same time. All right. Brains are good? Okay. So number 11. What is the measure of angle C? 60. What are the missing sides? 9 feet. 9 feet. Yep. Okay. Number 12. They have markings to show you that all three sides are the same length. So what are the missing side lengths? 24. And then what are all three angles going to be? Okay. All right. For the last problem, they tell you that PQR is an equilateral triangle. They give you three sides, and they want you to solve for x and y. So do you see how all three sides have y's in them? We do not need all three sides to solve for y. Just pick two. So which two would you guys like to use?
I did 14y and 9y plus 1.
Yeah, I'd probably use maybe the 11 because these two are smaller numbers, maybe? What do you guys think? Well, Alex, since you used the other one, you can tell us if we got the same answer as you.
And like if I don't, like you're wrong.
Yeah.
Never wrong.
And then, Alex, you can also tell us if our way was easier than yours or not.
Well, it's the same thing.
No, but it could be easier
Why?
because the numbers could be smaller.
But I don't do that in my head.
Okay, Alex, did we all get the same answer as you?
Yes.
Okay, was our way easier or harder?
It's the same thing. Wait, what the heck?
Was our way easier?
No, because I just did it a little small on both sides.
Okay. All right, and then how do we solve for x? Okay. How did we know it equals 60? Because it's equilateral, so all the sides are 60. Okay. So then we got 7x equals 63. 9. Niner. Okay. I think I'm going to have you do odds. Classifying triangles worksheet. You're going to do odds. Classifying triangles worksheet. You're going to do odds. Yeah, we'll do odds and odds. And if you want extra credit, you can do all. So we'll do. Yeah. When you guys do extra credit, I keep track of it, and then at the end of the quarter, I go back and I like add extra like homework assignments that you got full credit on. That's what I usually do. Or if I'm on top of things, then I will add it before the end of the quarter. But last quarter, I ended up adding it at the end. So. All right, sound good?